So now that we have everything done with the exception of our rendering and compositing, it is time for us to focus, well, on rendering. Now, most beginners in the world of 3D will go about setting up their scene, get the animation in place, cameras in place, materials in place, lighting in place, and then hit a render button. And they expect for the whole thing to look good. But the problem with that is they really leave no control over the final images. So if you found this light to be too bright or this color to be just a little off, you would need to go back in, make those changes on the various parameters, and then re-render out a scene.
Exactly, and if we were to have wanted to do that, we'd have had to spend a lot longer setting up all of those parameters on our lights than just throwing in the light and leaving it with a color of white and an intensity of 1.
A lot more testing. It would have just been a nightmare, and then in the end, inevitably, there would still be something that would need to be changed, and a final re-render would be required, and with the audience and everything that we've got going on in the scene, this would equate to a bit of time. So, in the professional world, you never find renders done this way. Renders are divided up into a series of passes, which Steve is going to talk about in just a second, and then those passes are taken over into a compositor, and Houdini just happens to have a very nice compositor built in, and these passes are then composited back together, giving an artist complete control over all of the different elements that were rendered out into separate passes. So if you did not like the brightness of these particular spotlights, you could adjust that by toning them down, or you could tint a color or do, as you may have heard in the past, color correction, things like that. But the nice thing is you get blazingly fast feedback, and that is the true reward from using render passes and compositing. So in this video, Steve's going to give a quick introduction to the concept of render passes, and then from there we're going to start talking about the Talented Ball project and how we're going to look at it in regards to passes and start dividing it up. And this is going to lead us into a discussion of a script that we're going to write. We're not going to get into all of the details of the script itself, but you're going to get a general overview of why the script would be handy to have with this project and what kind of information the script will be looking for. So with that, Steve, let me go ahead and pass this over to you first.
Fantastic. So I think you summed up render passes the best when you said it's a way of splitting up everything that's coming out of our 3D application into various smaller pieces and then bringing those all back together when we come to compositing.
Here's the pen. All right, do some whiteboarding. Show me what you mean.
Okay, so let's say we've got our render and we've got a light in our render. I'm just going to say if we were to render out our final render, let's say we had an object in that render and we had a light coming in from here, so we got a light. Then we got a light coming in from here. So we have two lights coming in our render. Now, what if we were to want to split this up into passes? Well, we could take this and we could make it look like a series of different images. So we could have this light in a pass on its own. We could have another image that had the light coming in from this side in a pass on its own. We could even go as far as saying this is the diffuse for those lights. So we're not getting specular highlights, we're just getting general lighting on the object that's sitting here in those lights. We could break this down even further into other passes where we have, a specular highlight on the top of this would be our ball. A
So the specular highlight from the light on the left.
And maybe we've got specular highlight from this guy. What about shadows? Let's say we had shadows being cast here and here. What if we were to break this down and say, okay, we could have a pass for our shadows for this particular light. So we could have a shadow in a pass here and another pass with shadows. So it's a way of taking this final image and breaking it down into a series of smaller components. These components are now 2D, which means they're very quick data to work with. It's just an image file, and we can take all of these and bring them back together through compositing, which I'm going to make a box that I'm going to call compositing, as I probably run out of room. Compositing.
Yeah, you can make it. Yeah.
Through compositing, we then feed out a single final image and bring all of this back together into what would look like our original, but now we have complete control over each of these individual elements. We could completely remove one if we wanted to. We could dim down this particular light. We could dim down specular highlights on a particular light.
Change the color of the specular highlight. We could change the color of just one of the lights or both of the lights.
We could change the color of the shadows.
Exactly.
So we have, in the compositing stage, we now have complete control over working with each of these images as separate data. If we were to just take this into compositing, we'd have to work as this whole image as one thing. We couldn't get access to this light on its own or this shadow on its own. So it allows us to basically break apart our final render into a series of components that we can deal with individually, work with those individually, change them, then bring them all back together into a final image that will now look a huge amount better because of that control that we had. And also, let's say that for some reason we were really happy with this spotlight and the specular highlight and the shadow from it, but for some reason the animation on this spotlight we weren't happy with. We wanted to go back and we wanted to change it. We'd only need to re-render this pass, the specular highlight from this pass, and the shadow from this pass, whereas before we'd have to re-render the whole render, which means that we'd have to recalculate this light again, the specular highlight from this light again, the shadow, so we'd be wasting a huge amount of time, whereas here we only re-render what we need to change.
If you're working with a team or for a supervisor, this is fantastic. If you had someone else come to you and say, it looks pretty good, but could you just change this? It'd be really nice to say, well, have a seat. Take a look at this. What do you think? As opposed to, okay, well, check back with me in 2 hours and I should have the new render completed.
Exactly, because now you can just dim down a light and you don't have to worry about re-rendering because you just change your settings in compositing. It's just dealing with 2D images. It's a lot quicker. There's no rays being sent around. There's no illumination calculations. You're just dealing with pixel values and color pixel values. So it's very quick to evaluate. So the director could sit in on a session with a compositor and the compositor just be changing values and getting the exact look the director was after.
Exactly. All right, so with that, let's go ahead and pull up a new sheet and begin the discussion of our scene, starting with what kind of passes are we interested in.
Exactly, and I already kind of hinted at the passes we're going to be using when we did that demonstration. So we're going to be using 4 different passes. We're going to use diffuse, which we can imagine as, say we had our light that was only emitting diffuse, it wasn't emitting specular highlights, it didn't have shadows. That's what a diffuse pass would look like. It would be various tones in color and shading, but no specular highlights and no shadows.
Yeah, it's the primary color of the scene of all of the objects. If you will.
So let's say we had a sphere with a light, it would maybe, we'd have darker areas here and some mid-tones here and lighter areas at the top. We're also going to be using specular passes, and that's going to allow us to imagine that we had a light that was only emitting specular light. So we can now deal with the specular emission of a light separately from the diffuse, which means we'd have something like our object with just the specular highlight in a pass. That means that now, say we'd rendered out this object from one particular light, we were happy with the diffuse, but we were like, whoa, that specular highlight is way too bright. We now can come in and without re-rendering, we can dim down the specular component just on its own. We're also going to deal with shadows separately because it makes sense to be able to control shadows without having to re-render the diffuse and specular passes. So we're going to have shadow passes. Now the 4th pass is probably the least obvious pass because it's not something we mentioned in the previous discussion. This is going to be a depth pass. The depth pass is interesting because it contains, for our image, it's going to contain the depth of each pixel in our image, the object in that.
What he's
from
getting
the camera's view, the depth from the camera
from
of
the
that
camera
pixel.
to each pixel, how far away was it?
So say we've got our object here that's close to the camera, this would have a closer, so smaller value than the rest, which is further away from the camera. So it allows us to look at our scene and work out, well, how far away is this particular pixel from our camera or this particular pixel from our camera? And because of that, we can do things like depth of field, where we have our, distance is blurry and our foreground is out of focus, but we have a central area that's in focus because we know about the depth. So now we can say, well, at a depth of 30 units from our camera, we're in focus, and then we're going to go out of focus a certain distance in front and behind that. It also allows us to do things and say, okay, well, let's take the rear, the background of our scene, and darken this down so that we have darker areas at the back and come to lighter areas at the front. It even allows things like controlling color over depth. Say we were doing an underwater scene, color diminishes in depth, and things like red light and green light die out quicker than blue light underwater. So you could kill out your reds and greens over depth quicker than you were killing out blues. So you have a huge amount of control by rendering depth passes. So we're going to use depth passes as well as diffuse, specular, and shadow passes.
Now you did hear a second ago where Steve was talking about depth of field. from a camera. And of course we do have that ability inside of Houdini itself, but once again, let's say you didn't like the look of the depth of field that you got from a particular render. Now you've got to make some tweaks and you've got to re-render.
And not only that, depth of field calculating in 3D and rendering is very slow.
Yeah, it's very expensive.
It's a very expensive operation, whereas depth of field in 2D is nowhere near as expensive. We have complete control over changing depth of field parameters, and we can actually see pretty much in real time the effect that those parameters are having, which is not a luxury that you get when using it in 3D with a renderer.
And that's why Steve is going with this approach for controlling our depth of field. Plus, once again, we'll be able to use depth for other things as well.
Cool. So we can really break these down into two distinct groups. Our diffuse, specular, and shadows are really the lights and the objects those lights affect. We can think about diffuse, well, that's relating to lights emitting diffuse. Speculars are relating to lights emitting specular, and shadows are cast by lights.
So go ahead and put lights and objects.
And objects. Depth is a special case. Depth is only concerned with objects. We don't care if an object is illuminated or if it's in darkness, in shadow. We only care how far is that object from our camera at the pixel we're rendering. So depth is a special case and is dealing with objects. So we're going to talk about depth a little bit later, but for now let's talk about the three main passes, our diffuse, specular, and shadows, and talk about this phrase, lights and objects. Well, what if we were to draw a line?
Up.
Wait.
You always got to click first. There we go.
Cool. So what if we were to draw a line and come down here and do a table dividing our objects and our lights? So let's create objects on this side. So objects. And let's, on this side, create lights. So let's think about our objects, the objects that we have in our scene. Well, we've got our character. He's an object. So character. We've got our audience and our stadium, and we could consider those as the bleachers object, but actually it would make a lot of sense to have separate control over our audience from our stadium, because let's say we had a light illuminating our audience. We got that top light illuminating the audience and we were happy with its intensity, but then we were to look at how that's illuminating the benches and we're like, oh, that light's kind of bright, it's too intense for what we're going for. Well, what we can do is, if we were to split these into two separate objects, we then have control over the audience separately from the stadium, and that's what we're going to do here, to give full control over how one light affects the audience separately from the benches the audience are sitting on.
Very nice.
So we're going to have an audience object, and we're going to have a stadium object. Now, unlike the audience and the stadium, the pool, the stage, and the ladder, we don't really need to work with separately, because I'm very happy with how the lights were interacting with them as a whole. So we can kind of group those together and think of those as maybe an object that we could call the set. So let's say we have an object called the set, and that object is really comprised of the true objects stage, ladder, and pool. And finally we have our floor object. And floor has been separated from set for a couple of reasons. Firstly, I do actually want separate control over the lighting on the floor, because we might not want the floor to get quite as bright lighting, because we don't want to bring attention to the floor. It's more of something we want to be subtly there. But also because of the way we're going to layer all these objects back together, because if we're breaking them apart, we're going to have to layer them back together in that final image. And we can think of layering things from background to foreground. Well, we got our set, and our set really needs to go over our audience and over our stadium, because we can see from our shots that the ladder sits in front of our audience, sits in front of our stadium. But our floor needs to go underneath our audience, underneath our stadium. So if our floor was grouped in with our set, we'd have to do a few more interesting things to enable us to layer the audience in between the set and the floor if they were in just one pass. So what we're going to do, we're going to break the set and the floor apart, so the floor is actually its separate object, and that's both for making layering easier and also for allowing us to have control over the lighting of the floor. So there are the objects that comprise our project. Well, what about the lights? We've got our main spotlights. So main spotlights, which you'll recall are main spot 1 and main spot 2. And we're going to group both of those spotlights together and call them main spotlights. And the reason for this, I'm very happy with how those two spotlights are working together. The light that they're casting works well together, so I don't feel the need to control each one separately. I'm very happy to render these as a very as a single pass, just have these as if they were one light now and deal with them as one light. You could break down for every single light, but then you're going to have more and more and more images to deal with, more and more file sequences to deal with, and eventually things become a little bit too complicated, and you're spending a lot of time managing files and not so much time actually managing the end result of the images. So where we can simplify things, like with the set, we've got the stage, ladder, and pool together, because I know we don't need controls separately on those. With our lights, we can group together our main spotlight 1 and main spotlight 2 into an overall group we'll call main spotlights. And we can take the same approach with our secondary spotlights. So secondary spotlights are really those 3 coloured spotlights, secondary spotlight 1, 2 and 3, the red, green and blue spotlights, but I know that we won't need to deal with those separately. We set them up to work together with the way they cast the light, so we can deal with those as a single object. We also have our character light rig, but our character light rig doesn't really make sense to have that as a single light, because we've got our rim lights in our character light rig, we've got our fill light in the character light rig, and we can kind of think of that bounce light being in the character light rig. But we've already seen that the bounce light is way too intense compared to the rim. Maybe we'd want control over the fill, so it would make much more sense to break down our character light rig into 3 distinct groups. We could have our character's rim light, which is actually both of the 2 rim spotlights. We could have the character's fill light, and then we can have the character's bounce light. So now we'd have control over these 3 different groupings of lights for the character separately. And finally, we've got all the lights that we've set up for our audience and for our stadium, and it would be really useful to deal with these separately as well. So let's think about it. We've got our bounce light for our audience, so we called that Bleachers Bounce. We've got the top-down light on our audience, so we've got the Bleachers Top. We've got the ambient light that we use just for our first shot. Well, I call it an ambient light. It's technically a distance light, but we've created an ambient light. So let's call that audience ambience. And finally, we can group together all of the rim lights that we've created for our audience and deal with that as a single light. So we've got our audience rim. So now we have a series of objects down here on the left-hand side that we're going to be dealing with, and a series of lights that we're going to be dealing with down here on the right-hand side. And we can start tying these together. We can start drawing links between these. Well, let's take a look at our main spotlights. Well, we know that our main spotlights illuminate absolutely everything. So we could go ahead and draw lines joining main spotlights to character to audience. I'm not going to, because we know that they illuminate everything, and things are going to become a little bit cluttered as we start drawing all of these links between them. But just in your mind, imagine that main spotlights has a line drawing to character, audience, stadium, set, and floor. Secondary spotlights, well, we've seen that they do illuminate everything, but I did mention when we were setting them up that we're not interested in them, the secondary spotlights, casting any illumination on our audience and stadium. It wasn't something that artistically I felt was needed. So secondary spotlights, we can really say, light our character, light our set, and light our floor, but they do not light our audience and our stadium. Let's take our character's rim, fill, and bounce. That's really a no-brainer. They light our character and they don't illuminate anything else, so we're going to say, okay, our character rim, character fill, and character bounce only illuminate our character. Well, what about our bleachers bounce and our bleachers top? Well, they illuminate our audience and they illuminate our stadium. Doesn't make sense for them to illuminate anything else. They shouldn't be illuminating our character, our set, or our floor. So let's say that bleachers bounce and bleachers top illuminate our audience and illuminate our stadium. And finally, we've got our audience ambience and audience rim, and that's going to be audience only. We don't want them to illuminate the stadium because they were designed to illuminate our characters and not the stadium. And again, for the same reason as bleachers bounce and bleachers top, it doesn't make sense to illuminate the character, set, or floor. So let's draw a line linking our audience. Now, if you imagined where I've got these groups of lights, that we actually had a line going to each one of these lights, each of these lines pretty much represents a pass. We could have our character, the secondary spotlights illuminating our character as a pass, the secondary spotlights illuminating our set as a pass, the secondary spotlights illuminating our floor as a pass, or we could have the character rim illuminating our character all as a pass. So each of these lines pretty much represent a pass, But we can go further than that, because each of these lines just really represents a relationship between a light group and an object group. So I'm going to scroll down a little bit further. And well, actually, we'll just come back up and talk about this for a second more. So we're dealing with light groups and object groups, but we've already talked about diffuse, specular, and shadows. So what if we were to say for each of these light groups, and for every object that they illuminate, we create a diffuse pass. So for each of these lines going from a light group to an object, since we know that all lights emit at least diffuse, we're going to create a diffuse pass to allow us to deal with the diffuse component of that light on particular objects separately. And then for specular, for any of these lights that emit specular, what if we were to create a specular pass for each of these objects that those lights illuminate? Well, you may ask yourself, well, why are we doing this? Obviously, we want to deal with lights individually. We want to be able to control the illumination on the main spotlights separate from our secondary spotlights. It makes sense to deal with objects differently, so we can say, okay, I want the secondary spotlights to illuminate the character more than our set, for example. But it also makes sense to be able to say, I want less diffuse and more specular, or more diffuse and less specular for each of those passes as well.
Steve, let me play the role of a student once
Sure.
again. Somebody that's watching this that might be new to this concept might be thinking to themselves, with these lights, you've grouped them together, and you've said that the lines indicate a single pass.
Mm-hmm.
So all of these character rim, fill,
No,
and bounce.
I actually probably said it too quickly. I'll reiterate. Imagine for these groupings that we've actually got a line going to each of these. It was just to make things more simple. So we'd have a character rim, a pass for our character. Precisely. With character rim. Character fill would have a pass with our character, and a character bounce would have a character pass.
I just wanted to make sure that was
nice
very clear, because if we did a single pass for diffuse that contained the character rim lights, the fill, and the bounce, we would really lose a lot of control, because let's say that all that needed to be adjusted was just the bounce. We needed to dim that down a little bit. You would then dim down your rim and your fill as well, and that'd be the last thing you'd want to do. So do imagine a bunch of lines connected there.
Yeah, it would just become a hectic diagram if I drew all the lines out.
It would.
So we've got an idea of diffuse and specular. Now with shadows, it would not make sense to have shadow passes broken down based on objects. For lights, sure, that makes sense. Our main spotlights are going to cast shadows, and it would be nice to control those shadows differently from the secondary spotlights and differently from the shadows coming from our top-down audience, bleachers top distant light.
Mm-hmm.
But on objects, it doesn't make sense to differentiate the shadows that are on a character from the shadows that are on our stage, because, to be honest, I'm very happy with how the shadows are all interacting together. And if we were to go to having the level of control over all the objects, we'd actually have too much control. Things would become very complicated. And also things would become complicated in setting up the render passes, because now you have to think of, how do I have an object cast a shadow in the scene without being physically present in the render? So it's a lot more complexity involved, and too much complexity for what we really need in terms of control. So we're going to have plenty of control if we can have shadows for our main spotlights separate to shadows from our secondary spotlights, separate to shadows from our bleachers top, but not have shadows broken down based on objects. So whereas diffuse and specular will be broken down based on objects, shadows will not. And depth is going to be, again, a special case where we're only worrying about we're not worrying about lights, but we're also not going to worry about objects, because if you think about it, depth is an absolute value from the camera. How far away is a particular pixel from a camera? So we're not going to want to modify that. We're not going to, for some reason, want to make our character further away from the camera than he actually is.
Right.
So it doesn't make sense to have control over the depth of our character separate to our audience, separate from our floor. What if we just had the depth of whatever we're rendering, and we just have a single depth pass per shot of all of the objects? So that's what we're going to do. So that's taking a look at different passes that we're going to need and how the lights and objects relate. But what about those passes? How do we actually create those passes when we're in Houdini? Well, I'm going to create a new page to draw on and scroll up to the top. So, well, we got our different passes. We got diffuse. And how do we create a diffuse pass? Well, we've kind of seen this without realizing already in Houdini. When we had a light that we only wanted to emit diffuse, we made sure we weren't emitting specular on the light by unchecking the specular contribution, which if we jump over to Houdini and find any light, let's grab the bleachers bounce, we see that we unchecked the specular contribution, so we are emitting diffuse but not specular. We also made sure we didn't have shadows on. So for a diffuse pass, we want to make sure that we turn off the specular contribution of a light. And also make sure that we turn off shadows for a light. Well, what about specular? Well, specular's very similar, but instead of turning off specular contribution, what if we were to turn off diffuse contribution? Then we'd only have specular, and if we were to make sure we also turned off shadows, we wouldn't get any shadows getting in the way, so we'd have just the specular component. So let's make sure for a specular pass that we'd go in and we turn off our diffuse contribution, and again turn off shadows. And finally, with our shadow pass, I say finally because we've got our depth pass to come in a second, we're going to have to do something a little bit special, because to render out shadows we kind of need to tell Houdini to work in a different way, tell the Mantra render engine to work in a different way. And coming built in with Houdini is a fantastic shader called the Vex Shadow Matte. And what that does is, if you assign that to your objects, instead of seeing anything in the color channels of a render, the color channels will be black. What we're going to see is in the alpha channel of the render, we're going to see our shadows. So if you imagine that you had a scene set up, let's draw something out where we've got a box and a plane and a light somewhere up here, and it's casting light down, and we'd see a shadow down here. Instead of seeing these objects or anything in our image, what we'd have is a color and an alpha channel. The color channel would be completely black. The alpha channel would have white just where our shadows are, so it's an extremely useful shader. So what we need to do is, for a shadow pass, we need to tell Houdini to assign this Vex Shadow Matte shader, so Vex Shadow Matte, to all of our objects, so that we're getting all of the interactions of light and shadows between all of those objects. And then we want to make sure that we turn off specular for the lights, since we don't want to add to calculations. There's no need to be emitting specular because we don't need it. So let's turn off the specular for our lights. But we want to make sure that diffuse is on, because if a light isn't emitting diffuse, then what's going to happen is that light is then not going to cast shadows, because it's not emitting light, so it doesn't make sense for it to emit shadows. So we do need to make sure that diffuse is on, so that we get the shadows appearing in our pass. So that's how we're going to deal with shadows. And how are we going to deal with depths? Well, depth is a special case, as we said before, and we're actually going to deal with this outside of the render script that we're creating, because we only need a single depth pass per shot, and because setting up depth, you're going to see in a few videos time, is as easy as setting up a very basic parameter on our render node. It doesn't make sense to account for that in our script, because we can just go in and for each shot set up our render node, set up that very basic setting and tell it to render. So we're actually going to deal with depth outside of this system. So how do we actually, well, if we take a look, you can see that this is light parameters. So that's some light parameters. These are light parameters. These are light parameters. So we can see that for the most part, if we had a render script that could come in and set parameters on lights, if we told it I want a specular pass or I want a diffuse pass, and it could go in and set parameters on lights, for the most part we're going to be set. We only really need to concern ourselves with how we're going to get this shadow matte material assigned, and it's actually going to be fairly easy. What we can do is we can tell Houdini to temporarily put itself in a state whereby all of the objects have this material assigned, do the render for our shadows, and then come out of that state. And the way we're going to achieve this is using something in Houdini that's called takes. What takes allows us to do is we can create a take that we can call something like the shadow take, and in that take we can manually go ahead and assign this Vex Shadow Matte shader to all of our objects. And what that allows us to do is, when we're in that take, when that take is active, all of our objects are going to have that shadow matte. When the take isn't active, when we're in our normal take, everything's going to render as before.
Well, a very simple way that we can talk about takes is to say let's pretend that we have a simple sphere in the scene, and the sphere is going to be colored red. Now let's create another take where we change that color from red to blue.
Yeah.
Now if we tell the renderer, use our normal take, it'll render out red. If we say use this other take, it'll render out blue.
Exactly, and the exact same concept applies here, only instead of rendering between red and blue, we're rendering between normal shading and using this shadow map. And because of that, what we can do is we can tell, in our script, we can basically go ahead and tell the renderer, okay, for this particular render we're doing, make sure that you're rendering using that shadow take, but for all of our diffuse and specular, we make sure that we render using our normal take. So we're seeing some patterns appearing here, and what we can see is that we need a way of, well, if I bring back our layers and hide you and bring back hue, we need a way of describing which objects are going to be in a particular pass, which lights are going to be in a particular pass, and which pass are we rendering. So let's write that down.
So are you going to basically hide things out that are not
pretty much
included?
The render node, let's actually take a look at the render node.
Okay.
It makes sense to point this out while we're having this discussion. So I'm going to create a mantra render node, and the mantra render node on the objects tab has a fantastic section where we can set which objects we want to render and which lights we want to render. By default, it's set to the wildcard star, which is going to include everything. We can come in and through scripting we can change these parameters. So we can change the candidate objects, say, to just be our character, and we can change candidate lights to just be our main spotlights. If we then go in and modify the main spotlights parameters, setting it just to diffuse, well, there we've got our diffuse pass for our main spotlights for our character. So we're going to come in and we're going to modify this parameter and this parameter.
So if we modified candidate objects and had just our character ball in there, and then went into our candidate lights and included just main spotlight 1 and 2, and hit render with everything else visible in the scene, the only thing that we would see rendered out would be our character, illuminated by just those two lights.
Only those lights, doesn't matter which other lights are active, which other objects are visible. We're telling the renderer only include these particular objects and only include these particular lights.
And now if you were to take it a step further and have your script go into those two main spotlights and disable or disengage the specular contribution, now we have just rendered out a diffuse pass, mating up our two main spotlights with our character.
Exactly, and then we could go in and we could have the script go in and activate specular and disable diffuse, and then we've got our specular pass. We could have the script go in and make sure that we've got diffuse enabled, specular disabled, shadow set up, and come in, and if we created a take, we could switch over to that shadow take here again on our render node, and our script would now tell the renderer to render using that shadow take, so now we're getting shadows involved. So our script is going to be able to come in and change these, and we can see that really there's only those three things we need to take into account. Which objects do we want? So objects. Which lights do we want? And what type of pass are we rendering? Are we doing diffuse? Are we doing specular? Or are we doing shadow? And this can be thought of as a description of a render. So we can see that what if we were able to take these descriptions of a render, because they're very easy for us to say in English. It's very easy for me to say, okay, I want the character, I want the main spotlights, I want diffuse. I want the stage, I want the secondary spotlights, I want specular. That's so easy in English and it's so quick, but if we were to go in and manually do all this, it would be extremely slow and extremely tedious. So what if we could take this description of a render and make it so it's a text file? So we could type in to the text file. So we're dealing pretty much in English. We're saying, I want these objects, I want these lights, I want this pass. I want these other objects in this new render, I want these other lights, I want this pass. And we just keep listing simply objects, lights, pass, objects, lights, pass over and over in a text file. We'd end up building up a complete description of all the renders we want. If we then had our script go in, load in this text file, and for each thing set that parameter to the right objects, set the parameter to the right lights, set up everything for that pass, fire off a render, repeat. We'd be able to automate the whole process by simply typing into a text file in pretty much in English our descriptions of a render for every pass we want. That's a nice quick process rather than going in and manually doing it. Our script can then go in and do all of the work that we're talking about up here, switching over to takes, turning off specular and everything, and firing off the renders for our passes. And that's exactly what we're going to do. Coming up in the next couple of videos, we're going to describe what is this description file going to look like? And then we're going to talk about writing a script that's actually going to take in that description file and deal with our scene and deal with rendering out that file. And with that, that's going to conclude the overview of everything we're dealing with in the next coming up section in terms of render passes and in terms of our rendering script. So thanks a lot, everyone.